Every year, landslides kill more people than all other natural disasters combined. Often there's no warning, and the results are disastrous.
When you have that much earth moving all at once at that speed, it's a scary sight. It was coming down 75 or 80 miles an hour. You could not run it.
It was just a deafening sound, just a horrible, deafening sound. And it was just this big black thing coming down.
A short ferry ride across Puget Sound from Seattle in America is Bainbridge Island. A popular summer retreat, Bainbridge is now feeling the pressure of year-round residents trying to escape the congestion of city life. This pressure of development was evident in the shoreline cliffs when a recent landslide took the life of a local teacher and his family.
The slide hit the Heron family home with such force that the top floor was thrown into Puget Sound. Authorities say the remaining floors collapsed on top of each other under the weight of 2,000 tons of mud.
Dwight and Jennifer Heron and their two small children had been sleeping in the basement during construction of what was to have been their cliffside dream house. Dwight's brother Scott had been helping with the remodeling just days before the tragedy.
The neighbors were sitting in their hot tub and saw it. And then it sounded like just a freight train coming down the hill. And it just happened in just seconds. You know, the whole thing was over in 10 or 15 seconds.
He really worked hard on the foundation, and we're just hoping that maybe in one of that it collapsed and provided a area where they might be protected.
It tore apart everything I believed in. You know, you call it acts of God. That was just destroyed. It's like, we've chosen this house here. This house is going right here. I mean, the houses are so close together.
Why this particular house? In fact, it was only a matter of time. The steep sandy cliffs of Puget Sound never stop sliding. Winter rains and ocean waves keep them steep and very vulnerable to collapse. A year earlier, heavy rains and a landslide 2 doors down forced a temporary evacuation of the residents, including the Herons.
I don't think he was in denial about it. And he built quite a retaining structure behind his house, and it's still there. It just bent a little bit, but all in all, his retaining structure held. It's just that the slide came from, instead of 40 feet up, it came from 80 feet up.
Forces of nature are often underestimated. As population continues to spread into areas with an unstable geology, landslides are becoming an ever-increasing risk.
People's memories are short. I don't know, very short. I'm sure that somebody will build in there again. I'm sure that they'll go along and they'll see, oh, it's a nice piece of waterfront. Let's put a house here, you know.
The landslide that killed the Heron family is known as a debris flow. They're triggered suddenly and move rapidly, as fast as 160 kilometers an hour. And it's difficult to record one on tape.
This is a big sucker. In fact, I'm going to back up at this very moment. This camera location is not safe. I'm leaving right now. New camera location, new camera location. Here it comes. You'll notice the camera's a little jiggly. God almighty.
A landslide can be a torrent of mud like this one, or just a slump of earth shifting a few centimeters a year. But fast or slow, gravity is always the crucial factor.
Geologically, everything is opposing forces. There's the forces generally produced by heat, which is causing things to rise. That heat causes rocks to move in the deep part of the earth, the bowels of the earth, and it causes things to rise up. But gravity is inexorably pulling things down. And so anytime something is lifted up, there is this force trying to pull it back down. So gravity is like death and taxes, will happen, occurs, it's everywhere. And it can't be avoided.
In the neighborhood of Vista Royale in Southern California, residents are working against time and gravity. They've been told to evacuate. Geologists are warning that the hill behind their homes may start sliding at any moment.
I see that outside the hill is moving closer and closer and everything is coming up. And naturally, I don't know, one night it could be I wake up and everything is sinking or moving.
When residents moved to the area, most were unaware that the development was built on land that was prone to landslides, although supposedly it had been repaired. However, the culprit may be a 230 million litre reservoir built at the top of Vista Royale, which has since been drained in case of leakage. Alternatively, it may be the build-up of thousands of days of sprinklers and swimming pool runoff, unknowingly creating the conditions for a slide.
When the spa used to work, a lot of, being out here at night with the lights on, and we have the seclusion of not having a neighbor right above us, so we've got a nice big hill back there, which was real nice for a while, but it's the ally has become our enemy,
Finding a solution for this slide may take years, but geologists right now are on the verge of a breakthrough. They've put landslides under a microscope. The microscope is huge. Built into a mountainside in Oregon is the world's largest landslide laboratory. Here, geologists can simulate their own landslides. Today, they're starting with 12 tons of sandy soil common to slide-prone slopes. They want to see if they can start a slide from soil that's been beaten and pounded for hours. Could this hard-packed earth still turn into a deadly slide?
It's really sort of a fundamental issue about whether they move slowly or whether they move rapidly, because the rapid ones are usually the ones that kill people. And so being able to determine the conditions, both the hydrology and the materials and the slopes, that get us those fast ones is a critical hazards question.
The flume's 31-degree slope won't launch a slide by itself. For that, the geologists must add an ingredient common to most slides: water, and lots of it.
The vast majority of landslides are triggered by groundwater pressure, usually in response to rainfall. And so we're just trying to develop a better understanding of exactly how water pressures build up within a slope and how the water pressure evolves during the course of failure and affects the dynamics of the landslide.
After an artificial downpour, they start injecting water underground. They'll carefully monitor the pressure and weight of this water as it rises in the slope.
Let's go ahead and...
You know what?
If the tightly packed grains of soil ever loosen, underground sensors will instantly register the change in the computer shack at the top of the flume.
So I'm watching the moisture move into the soil, and it's starting to form a groundwater table at the base of the slope right now. As the groundwater table forms and starts to rise, then we'll start seeing some deformation.
Sometimes it's quite a bit, sometimes it's not very much, but almost always there's some rearrangement of the material at depth as the soil deforms and is creeping towards failure.
Often the failure is sudden and dramatic, especially with loosely compacted soils. They collapse quickly and slide fast. Surprisingly fast. Three hours into this test, the sensors show the dense soil hasn't shifted a millimeter, despite the fact the water table has risen to just a few centimeters off complete saturation.
So
if we could
it could be 0.25. This is as close to uniform distribution in steady state that we've ever had.
Well, let's go ahead and plug the surface.
They decide to add the last increment of water in the hope it'll make the difference. Gravel is spread to hold the surface. If it slides, they want the whole thing to go. After 1,300 liters of water, things start to get interesting.
We're at 45, 52, 52.
Okay. 6 degrees in the center. This is the section of the soil here which is now opening up. The grains are moving apart and it's starting to define a shear surface.
When a shear surface forms underground, particles of soil once packed together begin sliding past each other.
Okay, yeah, this is responding.
After 5 hours and 33 minutes, it's finally going. But it's completely different than a quick debris flow.
Extension's 33.
Here's the crack.
That's good. This is what we were hoping for.
A slow-moving slump breaks into great lumbering blocks bloated with water, sliding down the slope with implacable determination. Moving slowly, a slide like this can easily be outrun. But for any structures in the way, these slides are devastating.
A huge landslide has completely covered Highway 101.
Melissa 2, Billy 7, had all three been trapped in their home.
The 1982 El Niño storms were one of the worst disasters to hit San Francisco and highlighted the need to identify landslide hazards.
Involved in the slide, one fell on top of the other. The man who was
1982 came along, and lo and behold, we had 18,000 of these landslides in the Bay Area. They were everywhere. Killed 25 people, caused $65 million in damage. To me, this is a tragedy. My motivation is to try to help people to avoid these kinds of problems.
Few geologists are as skilled at recognizing the signs of a landslide as Earl Brab. He's located and mapped over 88,000 in the San Francisco Bay Area alone. One way Brab predicts future landslides is finding the forgotten traces of ancient ones. He uses aerial photographs, a 3D stereoscope, and a bit of intuition.
I tried to envision that I am a landslide, and how would I come down the hill? Where would I start? Because we're winding up with the end of the process rather than the beginning of the process. We have to, in our mind, recreate how that pile of dirt got down at the bottom of the hill. Crazy way, maybe, but it works for me.
Ground cover can conceal evidence of a landslide, but Brab has discovered a set of telltale signs.
For one thing, the drainage is usually disrupted. So you can see ponds and little wet places where the landslide has blocked the drainage and the water is ponded. In addition, very often the landslide is big enough that it will push a creek aside at the bottom, and it has a bulbous toe, easily recognizable on the photographs. Typically, they also have a very steep cliff at the top where the land has broken away, which we call a scarp. And and you have to really look for it. But there are things that look like railroad tracks coming down the hill. The landslide moves down through the center and leaves us a little bit of a ridge on both sides. After it moved down the center, it goes into the creek and you don't see it anymore. But these railroad tracks are still there, and if you train your eyes to look for them, you can find them.
It's no coincidence that landslides occur frequently in California. Geology makes it inevitable. Two tectonic plates on the Earth's crust meet here. Los Angeles sits at ground zero, surrounded by earthquake faults. The San Andreas Fault is squeezing the LA basin and lifting the surrounding terrain. The San Gabriel Mountains, the result. This expanse of fractured rock towers above LA at a height of 3,000 meters. Mike Bolander, an LA County engineer, and Lawford Anderson, a geologist, are investigating reports of a new landslide in the San Gabriel Mountains.
This is about as steep a rugged mountain as you can find anywhere in the world. It's not as high as some, like the Himalayas, obviously. It only goes up about 10,000 feet. But realize it's young. It's rising today, and it's eroding today. And that combination of rising today and eroding today is what gives you your steep, rugged relief that you find in any mountain range, and you have it right here. Wow, Mike, this is good. Look at that. It's got the whole thing. It's got a great scarp at the top. And look at all of this.
Those are some pretty big boulders.
This came down how recently? Last year?
I think this is within the last year, then maybe even within the last 6 months.
I mean, this stuff can be pretty tough to hike on because it's come down, it's now stabilized at the angle of repose. Anything steeper than that is very susceptible to landslides. Steeper than that, it's unstable. So this is right at that critical angle.
Most of the slopes in the San Gabriels are this steep, on average 70%, and at that angle, erosion is phenomenally high. 7,000 kilograms of rock from every 4 square kilometers per year.
It is poised. This whole thing, right now it's stabilized, but it's just temporary. It's just waiting to come down the rest of the way. The next rainstorm, the next earthquake, it's ready to come down.
Over 1.5 million cubic meters of rock come down every year from the San Gabriels. LA County engineers have reacted to the problem. In the 1930s, they began pouring concrete and pounding steel. Today, almost every canyon along the San Gabriel front has been barricaded. In more than 100, there are stadium-sized debris basins. It's all waiting to catch what the mountains throw at LA.
These debris basins are designed to protect the people down below from the forces of nature, from rain and erosion, rocks and boulders and mud and trees and things that come out of these canyons. And these local mountains, we can have Volkswagen, even truck-sized boulders coming down out of the mountains.
This is the battle that LA fights against landslides from the San Gabriels. It's a battle that one family came very close to losing. Bob and Jackie Genophile built a home in Shields Canyon. They didn't realize they'd put themselves and their children on the front lines.
We moved here in '59, and it was all perfectly peaceful and safe and very few homes above us. It was quite nice. The road above us, it was just a half a block up here, maybe a little more. There was a house on the end. And then a developer came along and it opened up the canyon all the way up.
In the 1970s, more homes were built further up the canyon. But that put the Genophiles' house at the bottom of a new 90-meter plunging stretch of Pinecone Road.
They had fixed a flood control channel next to us. You know, it was safe. There was a debris basin way above us. I guess it gathered a lot of water and that when it rained, and it went down the channel. But it didn't come down this street. There was never water down this street.
This would all change in February of 1978, during one of the most intense rainstorms in LA's history.
And the storms aren't over. It's hailing right now. Occasional rains are expected for much of this week, with heavy rains on Wednesday.
Usually when it rains, noise from that channel is unbelievable. It's like a big railroad car had broken loose or something. But this night it was quiet. And I thought, gee, that's strange. But I got up to be sure the windows are all closed over there.
The storm channel was quiet because it was blocked by a 2-meter boulder. And further up the canyon, a landslide was quickly filling the 4,500 cubic meter debris dam. Gravity and the steep grade down Pinecone Road would deliver it all to Jackie and Bob Genifile and their 2 sleeping children.
I came back in the house, my husband as usual. It's okay, come back to bed, don't be so concerned. Well, the next thing you know, my daughter's mom, come here, something's wrong. And she said, there's too much water in the street, I don't understand it. And here's all this water coming down and mud and what have you. And, but there was a truck coming down.
Rudy Rico, a crew chief with flood control, was driving that truck. He was out in the weather all day checking on Shields Canyon.
Me and my crew were expecting something to happen, but not of this magnitude, okay? And the debris that came out of the Shields Canyon overtopped Shields debris basin, and it was one big nightmare. The truck started to shake like an earthquake, but I knew it wasn't an earthquake, I knew it was a landslide. It wasn't moving at 20, 30 miles an hour. It was coming down 75 or 80 miles an hour. Their home was right at the bottom of the street. Their home was right in the way.
I can't explain it. It was just a deafening sound. Just a horrible, deafening sound. And it was just this big black thing coming down. I screamed, we're being flooded, run. And I remember Bob saying, oh my God, I hope our roof holds. But by the time we got to the bedroom, which isn't very far, my husband, and then by this time mud is coming in, and he screamed for us to jump on the bed, and my son at that time came running, and the door broke, and then it just kind of enveloped the whole house. We were so high on our bed with the mud lifting it, we had our hands on the ceiling, but the kids were trapped down here. My husband tried to dive through the stuff. They were buried up to their chest. And of course, they gave us up for dead, naturally, you know, when it hit.
In the heavily devastated Pinecone Street in La Crescenta, the cleanup continued today. The street was a raging river. Rocks, mud, and debris roared down it with tremendous force, hitting homes.
Amazingly, the Genophiles survived. The mud rose all the way up to their chins before stopping.
A half dozen cars and 5 feet of mud still entrapped a house at the foot of Pinecone. All the debris ended there at the end of the street.
In that storm of 1978, 20 people were killed and hundreds of homes were damaged. At the northern end of Highway 101 in Washington state, a hillside suddenly came apart, covering the road with 12 meters of mud and cutting off a community. Once a landslide occurs, engineering geologists like Dave Finley are brought in to try to rectify the situation.
This is a little town of Lillowop. It's one of the closest little hamlets to where the slide is.
It's a remote stretch of road, and one that goes where no road should go. But it's a lifeline for the area, now severed by a huge landslide 610 meters wide. Clearing the slide and keeping the hill from sliding again is the challenge. Crews are working on it round the clock. They need to find a way to hold back the thousands of tons of mud that started giving way from the bluffs above the road. Heavy rainfall is often the main element behind landslides, but here there is another factor: crumbling rock laid down in the Ice Age.
They're separated here. See this fracture here? Along this part of the Hood Canal, a lot of these slopes have been oversteepened when the glaciers were here. They came in here and carved out and oversteepened the sides of this Hood Canal. And because it's oversteepened, the soils are not happy, they're not stable. And given time, that they'll fail until they do get stable and happy.
The slopes here are steep and covered with a layer of loose sand and gravel, both easily permeated by water. It all sits on a slippery layer of clay.
This is a driveway access that provides access to a home up the street here. This is just a minor secondary scarp within the landslide mass. There's probably what looks like what's left of their cable TV line. As you can see, it's been totally destroyed. And then it cuts right across through here and actually down dropped that whole western half of the house.
Over a period of weeks, the hill above Hood Canal came apart, carving its way 150 meters to the Swanson home. The slide turned a prime view site into an insurance claim. Somewhere under all the damage are the reasons it gave way.
It's right over in here, that scarp, that lateral scarp gets real fuzzy.
Yeah,
it's right here for sure, but
it's good there.
We haven't nailed it.
Firstly, the depth of the slide layer and whether it's still moving must be ascertained. That requires a drilling team specializing in steep terrain. Carbide drills can cut through bedrock easily, but it's having trouble with the loose gravel in the slide layer. The holes keep collapsing, and they have 38 more holes to go. What goes down the holes is an inclinometer, an electronic sensor that warns if the angle of this slippery slope starts changing.
They tend to move more like a glacier than anything. It's slow but steady. Rarely do you see the ones that, like on the news, where they just go.
Explosives are used. They're one of the latest tricks in the geologist's toolkit, and a useful way to get a look at the rock layers underground. They'll know that water is finding a way to accumulate under the slide layer. To find out why, they'll use a string of motion sensors, geophones, buried along a section of the site.
We have 24 of these. They're called geophones. They're basically, it's a motion sensor. It senses vibrations. So we set off an explosion, and then that will send an acoustic wave through the earth, and we can detect the motion along the line of that wave when it travels along and reflects off different layers in the earth.
Hey, this is Mary.
Sound waves from the blast move through the earth, bounce off the bedrock, and return, registering a layer-by-layer view of the slope, all in seconds.
This, combined with the seismic refraction work and the drilling, will we'll put together a very credible geologic model that we can evaluate the stability of this whole landslide with. And this is confirming our suspicions that it's is a very undulatory, irregular surface.
This irregular surface allowed so much water to collect under the loose gravel, it eventually weakened the entire hill. Geologists think that to finally stabilize this one, they'll need to drain more than 15 million liters of water per day. At least this landslide can be fixed. The most dangerous landslides are from volcanoes, and scientists have only just begun to discover their warning signs. Steep-sided volcanoes covered in snow pose the most extreme landslide hazard of all. An eruption can quickly melt the snowcap, sending a torrent of mud, ash, and lava charging downslope as fast as 15 meters a second. They're known as lahars. They behave like liquid concrete, entombing everything in mud as they rush downstream. Geologists consider Mount Rainier in Washington the most dangerous volcano in the United States. Chief Ranger John Cambrink will probably be the first to know if a lahar is starting.
218-600 on 3. It's spring opening at Mount Rainier, and people down in the Puyallup Valley are looking at tulips, and they're planting their gardens, and we are trying to remove up to 25 feet of snow from the roads that have been snowed in all winter long. Right here where they're operating, we have 3 operators. Jim and Mike and Joe are very seasoned operators, many years, many spring openings under their belt. And they're so used to it, the control, that they can feel it almost like walking. Now, further up here, if you look off in the distance where you've got some avalanche start zones and the steeper slopes, those are extremely hazardous areas. And they're really, really on their toes there.
The slightest misstep by these pioneering snowplows can turn a slope into a deadly slide. An avalanche can start from a layer of snow as thin as 15 centimeters. But with gravity pulling, it'll quickly build. Snowplows at Rainier have been swept right off the roads. A thick mantle of snow, 93 square kilometers wide, covers Rainier all year round. It's waiting to go in a lahar.
Because of the tremendous snowfall and the accumulation of snow in the glaciers, Mount Rainier has more water trapped in its snowfields and its glaciers than all of the other Cascade peaks combined. And if that was released because of renewed activity, volcanic activity, the debris flows that came off of Mount St. Helens when it erupted would look very minuscule compared to the debris flows that this would produce.
With all of its snow, Mount Rainier could launch a debris flow of enormous proportions down the Puget Lowlands all the way to Seattle. One scientist has discovered dramatic evidence that it's happened before. When a new sewer line was installed in a housing tract 48 kilometers from Rainier, some unusual clues emerged. Tree stumps from half a millennium ago.
These trees are part of a forest that was buried by this huge mass of mud and rock that originally sat on Mount Rainier, and then about 600 years ago, for reasons that we don't really fully understand yet, perhaps an eruption, perhaps a large earthquake, this mass of material slid away and flowed some 50 kilometers down the Puyallup River to this site where it buried these trees about 20 feet deep. For the Native Americans that were undoubtedly in this vicinity, would have been a pretty terrifying event. A huge flow of mud and rock, a lahar, from the mountain was carrying rocks of all sizes. We've seen some of the big rocks right near this site. They would have heard a loud rumbling sound, off in the distance. And then pretty fast, a big wave of mud and rock, maybe 20, 30 feet high at least, would have been breaking trees, crashing through this valley bottom.
Cutting samples from these perfectly preserved trees, geologist Pat Pringle uses the technique of tree ring dating to work out a date of 600 years for this catastrophic event. Other evidence points to lahars recurring every 500 years, which means another one is due. There are many towns in the valleys below Rainier. One of the first in the path of a lahar would be the growing community of Orting. School officials here have decided to take the threat seriously.
And what we're going to do is identify those kids as if they were getting in cars with teachers, so they're going to move away from the building. That's what you do in a real... You want to get those kids in the cars, and that's the way we...
Each May, they run an evacuation drill to prepare the town's 1,700 students for the worst-case scenario.
That's right. That's exactly it. In order for us all to be on the buses as quickly as possible, you're responsible for yourself, I'm responsible for you, and Mr. Kurbs is responsible for you.
We don't want them to have nightmares, we don't want them to have bad dreams, but at the same time, we need to have this in the back of our minds that we're ready to act if we need to.
And we're talking in terms of, we're not looking at seatbelt safety in this case.
Right.
How many kids could you get?
Scientists are saying is that we have an hour window, you know, a 1 to 2 hour window, but on the short side, an hour window, so.
Orting's survival plan is based on a simple strategy.
In talking to the scientists, what we've learned is that time is of the essence. So basically, we just want to get as many kids loaded as quickly as possible and get to high ground, which is safety.
The last lahar spread 56 kilometers into this valley. Tracing its path can give an insight into what to expect when it happens again.
In fact, this is about almost the velocity. Actually, we're a little bit faster than the mud flow is probably moving here. You can almost tell what the soil is made of around here. These cows are a sure indication that we're on the mud flow deposit. Really, I think any town in a valley draining a volcano should have a sense that this is a zone where previous mud flows have gone.
Over time, lahars have torn loose from Mount Rainier and inundated the valleys with a tidal wave of mud. Yet within this mud, scientists may have found a clue to predicting when the next one will be triggered. How do volcanic landslides start in the first place? New information has come to light about how they're triggered on Mount Rainier. Carol Finn, a geophysicist, is working on the investigation.
As a scientist, one of the things I really like are to solve problems. And I've studied volcanoes for 20 years in my career, so I can get more intimate knowledge of the pieces of it. Why are there landslides there? Or what is the trigger? Do you always have to have a big eruption and then you're going to have a situation like Mount St. Helens, a big eruption and then a big landslide? Or maybe you'll have a huge earthquake and then a big landslide. But what if you can have a big landslide just because it rains?
Using a new method for examining volcanic rock, Carol Finn has identified large sections on Rainier's craggy face that seem to be corroding from within.
You know, when a volcano forms, there's acids, basically, that go through the system, basically mostly through faults and fractures. They dissolve the rocks, as well as create new minerals, and those minerals have clay in them. And those are very slippery. So the rock slides off, mixes with the glacier ice, and moves. And the clay, once mixed within the other materials, they help the landslide go further. And so it's a double whammy. So the work that I'm doing is one of the first attempts to try to characterize the volume of these weak areas of the volcano in order to try to assess the stability of the volcano.
The work really begins up in the air with a helicopter team collecting magnetic data, flying tight survey lines back and forth over the volcano.
And the helicopter flew with a constant terrain clearance, basically. They flew constant elevation over the terrain, something like about 100 to 200 feet, so they're very close.
Volcanic rocks are usually very magnetic. If rocks on Rainier are corroding, the survey should see a significant drop in magnetic level.
It's a fairly focused view of the magnetic structure of the volcano. And that's one of the big advantages of it. We can see right through the ice. It doesn't care if it's magnetic, it'll show up as red on these maps. If it's not, it'll show up as blue. Now the red colors on here are the places where there are young volcanic rocks. Like for example, on the summit here, those are new volcanic rocks and they are very magnetic. Just what you expect. If you come over to the lower parts of the volcano on this side, this area right in here, and you see they're blue. They're not red, just like every place else. These are altered rocks, but these are old, and they're low on the volcano. They don't have much influence for landslides. So if we look up higher on the volcano, where we're much more interested, I can see the signature, blue on my map, telling me that the magnetic minerals are gone, enough to be a pretty weak area on the volcano.
It's not a matter of whether or not the volcano is going to renew its activity. It's not a matter of whether or not we're going to have debris flows or lahars off of Mount Rainier again, even at the magnitude we've had in the past. It's when.
In early November 1985, Nevado del Ruiz, a volcano in Colombia, began spewing ash clouds. Volcanologists thought it might be dangerous, but couldn't convince local officials to order an evacuation. On November the 13th, an eruption melted the ice cap, generating a massive debris flow. In just 2 hours, the town of Armero was wiped out and 23,000 people were killed in an avalanche of mud. Geologists estimate that most would have survived by walking for only 2 minutes to high ground, if only they'd had enough warning. Rick Lahusen of the USGS Volcano Hazards Program was in Colombia just after the Armero disaster. He's heard survivors talk about the sound of the approaching lahar.
In every situation where witnesses have been around a debris flow, they'll remark about the very obvious nature of the sound and the vibration that occurs. I've heard descriptions that it sounded like a helicopter approaching or a train approaching. There have been a number of instances where people have heard them coming, have been able to get out of their homes and get to slightly higher ground and get out of the way.
Lahusen helps develop an acoustic flow monitor, an AFM, that could be tuned to the sound of an approaching debris flow. He's installed these warning beacons in hazardous areas around the world. Once a landslide occurs, sound waves trigger their warning signs.
This is the brains of the AFM system right here, and it's a modular unit that's waterproof and can tolerate very harsh gases that volcanoes might emit. It's got a microprocessor on it, a program, a communication section, and then a lot of signal processing. And this is the part of the unit that continuously analyzes the signal coming from the geophone. A debris flow has a rather rapid rise in ground vibration as it approaches you. Amplitude, the strength of the signal and how fast it rises as it's approaching you is a characteristic. Another characteristic which is very important is that it is a very continuous signal. The rumbling goes on and on and on and on and on.
AFMs were first tested in southern China. Many tests followed, perfecting their ability to hear the subsonic ground vibrations of a debris flow.
This is an example of a debris flow that occurred during a typhoon, so there was a lot of background vibration, a lot of other noise, and we can clearly see that in spite of wind and the typhoon coming through, when this debris flow came through, it was a very, very pronounced signal. So it was very successful in seeing through the effects of a typhoon to
could see the debris flow as it passed, and then it receded.
AFMs have performed so well, 10 of them have been set up around Mount Rainier. If a debris flow starts, they'll give people down in the valleys a 1-hour warning.
600 on 1. We will be some of the first people to know. We realize that. It can happen in the dead of winter. It can happen during a busy summer day where the park is filled with thousands of visitors. And that's why these acoustical flow monitoring systems are really state-of-the-art, and they're quite experimental, but I think they can save a great many lives.
Geologists can't prevent landslides. Just like gravity, landslides are inevitable. But the more that is understood about how they work, and more accurately the predictions on where and when they will occur, the better the chance people will have of staying safely out of the way of a landslide.